Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will explain two-dimensional trigonometry with the focus on the sine rule and double angles. This is lesson 2 of 5. An aeroplane and a luggage truck are in the same horizontal plane on the runway and are equidistant from the foot of the airport traffic control tower. The angle made between the aeroplane, the runway, and the foot of the tower is alpha. The height of the tower above ground is h, and the angle of inclination from the luggage truck to the top of the tower is beta. Show that the distance between the aeroplane and the luggage truck can be expressed as AB is equal to 2h cos alpha divided by tan beta. Well, first of all, we are looking for the length of AB. And what we do is we will make the link between the two triangles, and that is side AC. We will make that one the subject of the formula. And we always start in the furthest triangle from the side that we are looking for. So we will start in triangle DCA. Triangle DCA is a right angled triangle since DC will always be perpendicular to CA. A tower and the ground always meets at a right angle. So in triangle DCA, remember you have to include h and beta. So the function that will work for you there is tan beta, since tan's ratio is opposite over adjacent. And we can say that tan beta is DC over AC. Then DC's length is h over AC. And then we can make AC the subject of the formula. Therefore, AC is equal to h over tan beta. Now we will move over to the other triangle ABC. But let's zoom in on the information that was given there. It was also given that side BC is equal to AC because they said that they were equidistant. Therefore, that implies that the angle there CAB, this is the angle at A, will then be equal to alpha, that one. And your reason is angles opposite equal sides. And now that you know the size of CAB, you can also work out the size of angle C. Angle C is BCA, and you can work that one out with angles of a triangle. Therefore, angle BCA will be 180 degrees minus 2 alpha. Before we continue, have you subscribed yet? And a reminder, you can also visit my website, Online Maths. The link is in the comments below. There you will find all the chapters in the syllabus. Please also feel free to leave a comment or like my video. Let's continue with the maths. Now we have all the information that we need. So from the previous slide, we worked out that little angle there at A was alpha, and the angle at C was 180 minus 2 alpha. So now we can work out the length of AB. So we will start by saying in triangle ABC, and we're going to use the sine rule. We can say AB over sin C is equal to AC over sin B. So let's substitute the angles there. C's size was 180 degrees minus 2 alpha equals AC over, and the angle there at B is alpha. Now we'll wait with AC just for a while. Here we can see a reduction formula. And we can reduce that one, sin 180 minus 2 alpha, to sin 2 alpha. And then to get AB alone, we will multiply by sin 2 alpha, and they will cancel. And what we do on the left, we do on the right. Now we can bring back AC. And from the first slide, we calculated AC was equal to h over tan beta. So in AC's place, you substitute h over tan beta. Now we will move over to sin 2 alpha, and we can zoom in there and you can see that that's a double angle. And then sin 2 alpha is the same as 2 sin alpha cos alpha, and now sin alpha and sin alpha will cancel, and you're left with AB is equal to 2h times cos alpha over tan beta. In the next lesson, I will explain three-dimensional trigonometry, more specifically the sine rule and double angles. Click on the video in the left-hand corner to take you straight to the next lesson.